Hello everybody, I'm just doing a quick voiceover explaining the strategies. So for the homework I put two different standards, and the standards that were included, the first part is all about patterns. And then after that it's going to be about fractions. The first thing is equivalent fractions. So, instead I'm just add a page here. That would probably be better. Yeah, I'm gonna add a page. Alright, so before I dive in, yeah, so patterns, basically the rule with this, with patterns, and for that the standard is 408.5. So you can also type in any YouTube videos, you can type in exactly 4.08.5, and know that patterns follow a rule. They have a sequence. A series of things happen over and over again, and you need to be able to predict a pattern, or at least tell the rule in fourth grade math. Predict what's coming next, or be able to see what was in between. And the next thing that we talked about was two things dealing with fractions. The first standard is 4.nf.1, and like I said, I like to type in the standard or write it so that you all can see it, and you could even see a bunch of other videos as well. YouTube has a plethora, plenty of them. So equivalent, okay, spell it. Russian. So equivalent fractions, or in the name like equivalent, it kind of sounds like the word equal. So know that all fractions are equivalent to each other. So if I said, I'm going to draw a circle here, two circles, so we can compare. Notice equivalent has to be equal. So if I said, okay, so one is shaded, one fraction model. And so I like to also, I tell my students, write the fraction of the fraction model. I see a total of two parts. The total is always your denominator, and only one is shaded. So equivalent fractions in this case, so if I still shade both of this, it's still the same thing. It's just cut into more pieces. So instead, it's four parts and it's two. So those fractions are still equal to each other. Also, if you were to compare 2/4 and 1/2, you would say you can cross multiply it, and 2 times 2 is 4, and 1 times 4 is 4. And you can also see both those fractions are equal. Now, with 4.nf.2, it's like comparing numbers, but instead it talks about greater than, less than, or equal to. And again, really, if they're equal, this is kind of like dealing with this. And also you need to know for any improper fraction, when the denominator is bigger, it's going to be greater than 1. Because if you know, all fractions are division problems. So 9 divided by 3 is actually equal to 3, and 3 is bigger than 1. And also, whole fractions are equal to 1. So if I said 8 divided by 8, or 7 divided by 7, those are equal to 1, because anything divided by itself will always be equal to 1. So it's like 1 is equal to 1. And then proper fractions, where the numerator is smaller, those are always less than 1. Or if I said 1/2, that's going to be less than 1, because that's actually 0.5. It's like saying 50 cents, which is greater. 50 cents are dollar. Obviously, the dollar is bigger, so that means all improper fractions are greater. Whole fractions are equal, and proper fractions are less. And again, there is a way where you can use their equivalent fraction. You can use your dump your brain and put your finger on your multiplication chart and drag it forward and backwards to see the equivalent fractions there. You can also, let me add a page. You can also multiply. So if I said 1/3 compared to 1/4, well, you can actually compare. I like to do it like let's say fifth grade adding or subtracting. is multiply the bottom, cross multiply the tops. Well, I know 3 times 4 is 12. So I'm having two fractions here, so I should have two denominators of 12. And then if I were to say 1 times 3 is 3, and that's on this side, so that 3 will be here, and 1 times 4 is 4, and you'll bring it down here, and you can see 4 is greater. And the equivalent fraction you would use if you were trying to see how to. This is the longer way, but I told my students there's always a shortcut way. You would have to multiply this by 4 over 4, 4 fourths, to equal 4 twelfths. And you would have to multiply this fraction by 1/4 if you were to drag that down. So you can multiply, you would have to multiply by 3 over 3, because 3 times 4 equals 12. So that would still give you this. Now also, I always tell my students, you can still cross multiply when push comes to shove. If I said 2/5 compared to 1/7, you can still just do that. 1 times 5 is 5, 2 times 7 is 14, which means 2/5 is greater. So let's dive right into the homework and explain this here. So, this one says, look at the pattern and what is the rule. The rule is what is following. So, if I look here, and I see that this 1 jumped to 4, and that 4 jumped to 7, and that 7 jumped to 10, and 10. So, I could see, am I adding 4? Let's see, is 1 plus 4, 4? No, 1 plus 4 is 5, so that can't work. And so I know we're not adding 4, so we can cross those out. Now where you add 3. So just, I see that I'm adding 3, and then 4 plus 3 is also 7, and 7 plus 3 is also 10, and 10 plus 3. So here I can see I'm not adding 1 at all. I'm just simply adding 3 over and over, and that's it, nothing else. Now here, they said, these geometric shapes follow a pattern. Which geometric shape would be next in the pattern? So if I see, I got a pentagon which has 5 sides, hexagon has 6, and then this is 4, 3, 5, 6, 4, 3, 5. And so what shape will be next? If you look at the pattern, a hexagon always came next, right? So that means I should have the hexagon. Yeah, it looks like a pentagon. Oop. Okay. Well, we already know it's the hexagon that would be next. So now let's look here. It says study what patterns are missing. So in order to get this right, I'm going to have to pick up on a rule. And that will predict. So if I can find the rule, I can find out what's missing. So we look closely here. I see 136, and it just goes that smaller and smaller to 130, 128. So apparently I am subtracting, right? And so now I see what caused 136 to drop to 130. And I can see you subtract 6. Right? And then after I subtract 6, 30 minus 2 is 28, right? And then again, I subtract 6. And then I subtract 2. So I see subtract 6, subtract 2, subtract 6. And next would be, so I subtracted 2. The next step would be subtract 6. And 120 minus 6 will be 114. And again, it fits because I subtract 2, which matches. And then 12 minus 6, we already know that's 106. So here we go. And here we go about Sam using a rule. Now, if I look at Sam's rule, these are the multiples of 5, but the multiples of 5 are simply just adding 5 over and over again. Right? So it's plus 5, plus 5, plus 5. So you're repeatedly adding 5. So if I look here, what did she do correctly? And they said which student made it similar to her. So that means the same rule, which is to add 5. So let's see which one adds 5. If I look at A, 9 plus 5 is 14, right? And not 16, so that's wrong. 13 plus 5 is going to be 18. And not 20. So again, these aren't following the rule. Now if I look 7, 14, 7 plus 5 is actually equal to 12, not 14. This is also wrong. But let's look here. 16 plus 5, 11 carry 1, that is 21. And then 21 plus 5 does equal 26. And 26, so I can see they are adding 5 over and over again, and this will be the only one that matches the rule, which is to add 5. Alright, see, make sure I ain't skip nothing. Alright, here, as you can see here, which of these could be missing in the input output table? So I see it's counting up by 5, 10, 15, 20. Next would actually be 25. Also 10, 20, 30, 40. I know it's 50. Also, if you notice, anything in here you're multiplying by 2, because 5 times 2 is 10. 10 times 2 is 20. So we actually have multiple ways we could have used to get the answer. So I already noticed this. Right? Now, Aang wrote a pattern. This is his pattern. What explains it? So we got adding, multiplying, dividing, multiplying. So I can see when we add, our number gets bigger. When we multiply, our number gets really bigger, like really big. And when we divide, though, our number gets smaller. I see this is just getting bigger and bigger and bigger. So we know we're not dividing because the number is not getting smaller. Also, adding by 4. 1 plus 4 is 5, not 4. So we're not adding 4. So now we're left with multiplying. Now, the difference is, B is saying multiply. Also, students have to make sure they pay close attention to the answer choices. Because look here, we both have 2 answer choices saying multiply. But one is saying multiply by 2. The other one is saying multiply by 4. So let's check. Is 1 times 2 4? No. 1 times 2 is 2. Again, 4 times 4 is actually 16. So I can see over and over, I'm actually multiplying by 4. And for it to jump that big like that, it has to be multiplying. Alright. Here, and we're actually almost done with patterns. Which number comes next? 5, 10. But it skipped 15. So look, I see I multiplied by 1. I multiplied 5 by 2 because 5 times 1 is 5. 5 times 2 is 10. And let's see here. I skipped 5 times 3. So 5 times 3 is not there. But it jumps straight to times 4 because 5 times 4, okay, is 20. And 15 times, so next after that, 5 times 5 is 25. But yet here, I could see they skip 3. They would probably skip 6. And that means they would go to 7. And then my answer would be 35. Alright. Kaylin was laying out her stars and rows. She did not fill row 3. So let's look at this here. I see she had 2 hearts, right? Then she had 4. So I see she added 2. And then she has 4. So that means she added 4. And really, honestly, it's like 2, 4, 6. So that means she would add 6 more to whatever was already there. So I see we got 1, 2, 3, 4, 5, 6, 7, 8. So the next thing, we're adding by the groups of 2's in the within the multiples of 2. Next you would add 6. So you would say 8 plus 6. And that would actually give me 14. And it helps to write the numbers well of hearts, so that we can kind of piece it together. Alright. Let's see here. This pattern here, I can see these numbers are actually getting smaller. Because 10 minus 3 is subtracting by 3. and they're not getting bigger, so we can't say add. Here I see 5, 10, 15, 20, 25, 5, 10, 15. I see we're not subtracting because nothing's getting smaller. In fact, we're actually getting bigger and bigger and bigger. And we're not multiplying either because 5 times 5 is 25. I see it just added 5 more over and over again. I'm not dividing again. My numbers are not being smaller. The only thing is add 5 because they are adding 5. Now, this is where it gets pretty tricky in a way. But if you understand what's going on, and students will have to do this on the test, they will have to look at fraction models and write equivalent fractions or compare. So the first thing you need to do is write the fraction of the fraction model. So let's see this here. Sokka and Toph found some chips. They brought the chips to Uncle Iroh's tea shop. They had 2/16 left of barbecue chips and 3/4 of tortilla chips. So here you see the amount they have. Now, after the meal, they had 1/2 of a container of Jenga juice left. Which fraction model represents an fraction equivalent to 1/2? So you could actually use your dump your brain for this. Or you can make an equivalent fraction by multiplying it by whole fractions that would make them have the same denominator. Or you can cross multiply. And so I look here, the first thing we need to look at the fraction model itself and write what fraction we're looking at. The total is always your denominator. So I see I have 1, 2, 3, and it's 4 groups, so that means that's 12. And I see 6 are shaded. Here's 1, 2, 3, and it's 1, 2, 3. So again, 4 and 3, that's still 12, and I see 8 are shaded. And we're comparing that to 1/2 to see which one is equal. 1, 2, 3. And it's 2 rows of 3, so that means that's 6, so that's 2, 6. And you're comparing that to 1/2 to see if it's equal. And 1, 2, so I see 2 rows of 8, which makes 4, and I see 6 of them are shaded. And again, I'm comparing that to 1/2. Now, if I were to go and I were to just do the quick way, I would say 12 times 1 is 12. 6 times 2 is 12. These are actually equal. But let's look at all of them. 12 times 1 is 12. 8 times 2 is 16. This is greater. Now, they didn't say greater. They say equivalent, which means it has to be equal. These fractions, whatever the fraction may be on the other side, it has to be equal. So, again, that's wrong. Also, you could have made 1/2 into a 12 by multiplying. And you could have said 6 over 6, right? Because 2 times 6 would equal 12. So you could have done it that way. But to me, this way is quicker and easier. 6 times 1 is 6. It's going to be 2 times 2 is 4. Again, this is greater. And we're not looking for anything greater than or less than. It only can be equal. 8 times 1 is 8. 6 times 2 is 12. Again, this is greater. So the only answer that's perfectly equal is A. Alright, let's look here. Which fraction is equivalent to the shaded portion of the figure? So if I look at this figure here, I can see already it has a total of 10 parts. And 6 of it shaded. So my fraction is 6/10. Now, if it already has the same denominator or like fraction, all I got to do is look at the numerator. So here, I see the denominators are same. And I know 6 is actually greater. Now, we need a fraction equivalent. So we don't need that. Again, I can compare this to 6 tenths, and 5 times 6 is 30. Oh, and 3 times 10 is also 30. These fractions are actually equal. Well, let's see why the others are wrong. Compare them. 6 times 6, 36. 4 times 10 is 40. Again, and this is an improper fraction. And obviously, improper fractions are always greater than 1. And this is a proper fraction, which means it is going to be less than 1. Let's go ahead and do this. 10 times 6 is 60, and 6 times 4 is 24. Again, this is not equivalent. The only thing that's equal to 6/10 is 3/5, and that's B. Alright, and now it said which fraction shows an equivalent to 4/5. Again, always write your fraction models. Even if you have to count the number of parts to get your denominators, you can. That writing a fraction is mandatory. That's your scratch work because it helps you think and keeps you from making a mistake. So I see there's a total of 2 parts here. There's a total of 6, total of 10, 6. There's 2 rows of 6, so that means it's 12. I see 1 part shaded, 2, 1, 2, 3, 4, and it's 8 shaded here, 1, 2, 3, okay. And you're comparing them all to 4/5. Now, if you're looking for something equivalent, which means equal, think about this. Can 5 ever be divided to make a 2? No, right. 5 divided by nothing is 2. So don't even waste your time. Now, can 5 multiply to be bigger? Because if you make an equivalent fraction, you have to multiply it by a whole fraction. If you want to make it smaller, you have to divide. So if I said 4/5, I would have to multiply it by something that 5 can make. Like I can multiply it by 2/2 and get 8/10. See how I multiply by that whole? If I wanted to make 6/10, or let's say 8/10, fit into a denominator that has a 5, I can do that because 10 can actually be divided to equal 5. So I would say divided by 2/2 because 10 divided by 2 will equal 5 and 8 divided by 2 will actually equal 4. But let's go ahead here. So I know 2 cannot make 5, so don't even waste your time. If I look 6, 5 can't even multiply up to make 6 at all. That's wrong. And let's go ahead and check the rest out. 5. Can 5 even make 12? That answer is no. 5 can't multiply and make 12. 5 can multiply. And so I'm looking at the denominator, if you notice. I'm really focused mainly on these denominators because that gives away if I need to waste my time using my dump your brain or not. Well, not waste time, but if I need to spend it up. And like I said, you can always cross multiply as well and see which one's equal. 8 times 4 is 40, and 8 times 5 is also 40. So this is equal. And you can see when I did turn an equivalent fraction, I ended up getting 8/10 anyway, but I multiplied by 2/2. And if you want to check this one, 12 times 4 is 48, 4 times 5 is 20. Again, the only one that was equal is this one. Okay, I think we're about halfway done. Alright, so let's see here. Iro gave Zuko this fraction below, brownies, and I see it has 3 parts and 2 are shaded. So the fraction is going to be 2/3 because, again, your total is your denominator and the number of parts shaded are the parts they're asking you specifically about. That's your numerator. They want to know which fraction is equivalent. So we need a fraction equivalent to 2/3. So again, let's make this fraction, write the fraction of the fraction models. 1, 2, 3. I see 3 rows of 3, which makes 9. And I see 6 of those are shaded. I see 1, 2. So I see 6 and 2 are shaded. And I see 1/4. Here, 1, 2, 3, 4. And it's 2 rows, so that's 8 4/8. So think about this. What can 3 multiply? If we want to get them to have the same denominator, we're going to have to multiply or divide within that dump your brain range. And with that being said, since we know we need a 3, not 3 can make 9, so we can actually do that one. But let's look at this. Can 3 make 4? Can 3 make 8? Can 3 make 6? So let's eliminate what 3 can't make. 3 times nothing will equal 4. 3 times nothing will equal 8. So let's look. Can 3 make 9? Absolutely. So let's see 2/3. And like I said, you can also compare this to 6 9ths. And 3 times 6, that's 18. This is actually equal to each other. But let's see what's wrong with D. If I were to compare this to 2/3, 6 times 2 is 12. 3 times 2, that's 6. Again, that's greater. And we don't need anything greater. It has to be equivalent, which means equal. Alright, which model shows 1/3? They want to know an equivalent fraction. So here I see I have 1, 2, 3, 4, 5, 6. My denominator is 6. 1 part is shaded. Compare that to 1/3. Alright. And I see actually all of these fractions have 6 in it. So this can actually save me some time if I were to go ahead and make an equivalent fraction with a denominator of 6. So I need to multiply it by something that would give me a denominator of 6. And then you got to ask yourself, 6 times what? 3 times what, I mean. 3 times what is going to give me 6? 3 times 2. The only way to make an equivalent fraction bigger is to multiply by a whole fraction with the same number on the top and bottom. And then I just multiply straight across. 1 times 2 is 2. 3 times 2 is 6. So the only fraction here, I see this is a 6. That's a 2. That's a 6. And that's a 4. And this is a 6. And I see 5 parts are shaded. The only thing here that matches that is this. And if you were to double check and you compare this to 1/3, 1 times 6 is 6. And 2 times 3 is also 6. So this is truly equal to each other. Alright, now, this one is a weird one, but here's the thing. I see a total of how many squares? That's right, 5 squares. And how many squares are shaded? That's right, 2. So, since I know that, and I gave you guys a hint here, I wrote the total number of blank, so that's the total number of squares, the numerators are shaded. They want to know which 2 expressions are equivalent to the fraction model. And here you're going to have to add, because we know we need 2/5, and so 2/5, or it can make an equivalent fraction as well. So let's check here, and let's solve this. 3 plus 3 is 6, the denominator stays the same. 5 plus 5, 1 plus 1 is 2, the denominator stays the same. And I see we got 10s here, we got 5s. Here, all of them are 10, so that means our denominator will stay as 10. And 2 plus 1 plus 1, that's going to be 4 tenths. And here, 3 times 2 is 5. My denominator stays the same. And 5 divided by 5 is always equal to 1. Again, 4 and 2 plus 2 is also 4. And again, that's equal to 1. Now, our fraction is an improper fraction. We're not working with a whole fraction. And with that being said, any whole fraction is wrong because it equals 1. This is going to be less than 1 regardless. So now, let's see. 5 can make 10, and 5 can stay as a 5 as well. So let's look here. Let's make 5 a denominator. So let's go ahead, 2/5. Let's compare it. 10 times 2 is 20. 5 times 2 is also 20. That was equal. 5 times 2 is 10. 5 times 2 is also 10. So this is also equal. Now, 10 times 2 is 20. And that's going to be 30. This is wrong because we need something equivalent, which means equal. The only 2 I had that were equal was B and C. Alright, and this one, which fraction is equivalent to the unshaded area? Unshaded. Ooh, I didn't see that before. So that means I got 3/4. And so that means you're going to have to deal with 3/4. You can multiply it by 3/3. Just anything. Multiply it by any whole fraction. We can't divide it because you can't divide 3 and 4 into anything smaller. You can divide 4 and 2, but you can't divide 3 any smaller because it's prime. So I can multiply by the whole fraction, 3/3. And 3 times 3 is 9. And 4 times 3 is 12. That's equivalent, right? I can also say multiply by 2/2, and I would get 6/8. So just knowing, you can even use your donkey brain and just put your finger and thumb on 3/4 and just scroll and make rows of it. Alright, which fraction isn't written in simplest form? Now, in order simplest form, you need to understand that means it is the smallest it can be. They are absolute prime numbers at this point, or just have nothing in common. So if I look here, and they say isn't. So if I look at 1/2, you can't make 1 any smaller, and you can't make 2 any smaller in this case. So that's already simplified. 2 and 5, that's already smallest. Neither one of them could be divided and make any smaller. 3/4, again, you can't do anything. Now, because I can divide 4 by 2, but I can't divide 3 by 2. It's just, you just have to leave it at 3/4. Now, 6/10, I can actually make this smaller, because if I were to use a T-chart and I were to put 6 and 10, and I'll put 1 times 6, 2 times 3, 1 times 10, 2 times 5, they can actually both be divided by 2, because they have 2 in common as a factor. So I can divide this by 2 over 2 and end up getting 3 over 5 and get 3/5. So my bottom line is this can actually be made smaller. So D needs to be made, so it said which isn't written. So again, don't get caught up in just saying, oh, I need the simplest. This one said which isn't. So you have to also pay attention exactly to what the question is asking you. Here, which shaded area is equivalent to 10/12? Look at this. 1, 2, 3, 4, 5, 6. 6 parts. And I see 3 are shaded. Oop. Here I see 1, 2, 3, 4, 5, 6. Again, 6 parts, 1 shaded. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I got 12 here. And 1, 2, 3, 4 are shaded. 1, 2, 3, 4, 5, 6. And 5 are shaded. You're comparing them all to 10/12. Alright, now you can actually make 10/12 smaller if you were to think about it. You can actually divide them both by 2 and end up getting 5 over 6. There's actually a fraction that matches exactly that, and that's right here, 5/6. And if you were to compare it to double check, 6 times 10 is 60, and 5 times 12 is also 60. So this is your only equivalence. Alright. In what box would you place a 4 to make the equation true? That means they all are talking about equivalent fractions, because I see an equal sign. I see an equal sign here, 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 and here. Now, you have to place the 4. So if I said 3 times 4 is 12, 1 times 12, this is equal. But if I put a 4 here, 3 times 4 is 12, but 2 times 12 is actually 24, and this is wrong because it's not equal. So if I put a 4 right here, that would be a 16, and this will be a 36. Again, we need it to be equal because I see all the equal signs. And then if I put a 4 here, that'd be an 8, and 12 times 1 is 12. So the only thing that is truly correct and equal, if I were to put a 4 there, would be A. Again, also make sure place a 4. It tells you what to do and make the equation true. Keywords in math, and really any subject, they give the answer away. You just have to pay attention. If you don't pay attention to the keyword, you will make a mistake and solve the wrong problem. Alright. We are almost done with this video. Which two models represent a fraction that is less than 3/5? Now, you got to pay close attention. It has to be less than. Now, you can cross multiply it and find it and see which one. Or, since we know all of our denominators apparently have to be 10, excuse me, because I clearly see a 10 here, 10 there, 10. As all these denominators. And 5 can make 10 very well. So let's go ahead and make an equivalent fraction to 10 so I can go ahead and compare them. And what can you multiply by 5 to equal 10? And right, it would be 2 over 2. Because 2 times 5 would be 10. But now let's do the numerators. 3 times 2 is 6. So 6/10 is equal to. Now, even though we got our denominator, 3/5, let's use 6/10. If the denominator is, so if the numerator is greater, right, we need something that's less than. So let's look here. If we compare this to 6/10, or you can even keep it the same, like I said, and compare it to 3/5. That'd be 30, 30. We don't need anything equal to, right? They said which is less. That'd be 30, 25. This is less than. This is going to be 30, and that's 35. This is greater. This is going to be, well, you actually don't have to cross multiply here because we already got the 6/10 right here. And 6 is obviously greater than 3. Now, they didn't say greater than. Right? They didn't say anything about being greater. So really it's 2. Yep, I did say which 2. I was going to say this is obviously, that's a 15. And that's going to be less than as well. So again, this has a less than. This is greater, so that's wrong. This is also less than, and D was equal. Alright, so this one says compare each fraction to the benchmark fraction 1/2. On the state test, you will see a question probably a lot like this. Every year they have one like this where you just have to compare. So if I were to compare 3/5, that means I need to separately go ahead and compare 3/5 with 1/2. I need to 3/4. I mean, I also need to compare 5/6 with 1/2, and I do need to compare 1/2 with 4 fifths. So 3 times 2 is 6. 1 times 4 is 4. I can see that's greater. 2 times 5 is 10. 6 times 1 is 6. This is going to be greater. And it's going to be 2 times 4 is 8. 1 times is 5. So I can see actually all of them are greater than 1/2. So not less than. So they can't come here. But they were all greater because they were bigger than 1/2. Alright, so which fraction is closest to 1? Alright, so if I look here, I can go ahead and compare them to which is closest to 1. Obviously, this is not, because if I were to draw fraction models, right? I say 1, 2, 3, 4, and I say 1. That is barely the whole thing. They want to know which is closest to the whole thing being filled out. If I look at 3/4, that's most of it already. If I look at 1/2, that's only half of it. And if I look at 1/3, that's only a little bit. So these are just way too small. But if you were still saying, well, I still can't compare, you could make a fraction model and see it, or you just have to compare them with each other, and the greater fraction will be the one that's closest to 1. Gosh, it's already 8 o'clock. Okay. 4 times 1 is 4. 3 times 2 is 6. So that means 3/4 is actually the bigger fraction and it's closer to 1. Alright, so again, which fraction is from least to greatest? Least to greatest. So, or should I say greatest to least? Let's see. I think I meant to put greatest to least. But if, for the sake of it, I understand. I won't count this question against the students. Greatest to least. So if I look here, no, it's good. It's original. I can keep this. Alright, so I can tell all improper fractions are greater. I do have an improper fraction here because 16 is bigger than 4, and actually 16 divided by 4 is 4. So let's go ahead and list least to greatest. The smallest thing I'll see here is 8/16. Right? Which is really like you divide it both by 8, you would get 1/2. So this fraction is equivalent to 1/2. Next, I also see another improper fraction. And again, all proper fractions are less than 1. So I got it right here. Proper fractions are less. Whole fractions are equal because anything divided by itself will always equal 1 anyway. And all improper fractions are greater than 1. So next will be the whole fraction that actually is equal to 1. And then the last thing, 16/4, which is actually equal to 4 because 16 divided by 4 is 4. So here I labeled it from least to greatest, and the only answer choice that matches that is C. Alright, and here I'm just not going to worry about writing a sentence. I just want you to understand how to compare. So 36, 36. These actually are equal. These fractions are equal. Almost done. Okay, students in Miss Santiago's class math were asked to tell y to fifth is less than 4/7. Whose reason is best? So let's see what answers don't make sense. See, now we're not adding anything here, are we? That's a no-no. And then fractions are division problems. Like, what's going on? We're not even adding fractions here. You can't just do this. So this makes no sense. 4 is greater than 2. Again, we're not talking about whole numbers at all, are we? We're talking about fractions, not whole numbers. And again, 7 is larger. No, again, this is a whole number, and we need to talk about a fraction. So just by process of elimination, I'm actually able to find this out. Now, if I also look and compare this, 5 times 4 is 20, 2 times 4 is 14. I can also see that this fraction, so yeah, 4/5 is actually closer to 1. That means it's a bigger fraction. It's greater than 2/5. And as you see, the alligator mouth does eat 4/7. Now, this one here, Muhammad needs 1/2 cup of sugar for a punch recipe. He also needs 5/8 cup of sugar for a cupcake recipe. Muhammad told his mother he used more sugar for the punch. Is he right? So he is saying the punch, that's 1/2. He's comparing that with 5/8. Now, that's going to be 10. That's 8. He's saying this is greater, which is actually a lie because 10 is bigger. So Muhammad was wrong because he said 1/2 was greater. Now let's look here. Which fraction is the smallest? You need a fraction that is less than 1, right? You need a fraction that is proper because it is less than 1. Alright, so let's look here and let's do some eliminating here. This is an improper fraction, which means it's greater than 1. And actually 15 divided by 5 is 3. And that's bigger than 1. 4 divided by 4 is actually equal to 1. I don't need equal, I need smaller. And now you're comparing 1/2 because that's left. They're both proper fractions. Now the smallest fraction between the two, you can actually compare these. Like, let's let them have a race. Who's the smallest? 2 times 3 is 6. 1 times 4 is 4. So 6 is bigger, and we don't need the biggest one. That means, hold up, we can't keep 3/5. He's bigger. 3/4, I mean. 1/2 is the smallest one on here. Alright. We have come so close into the end. Simplify the fractions first. So let's make these fractions as small as we possibly can. So I see 6/16. And I also see 12/20. Now, if I were to use my dump your brain for 6 and 16, I can see what factor they both have in common, so I could divide. I can divide them both by 2, right? And I can't use 3, I can't use 4 for 6. They both can be divided by 2. And I would end up getting 8 3/8. Because you have to also divide straight across. Now, if I can make this smaller, I know 12 and 20, they actually both can be divided by 4. And the reason why I'm getting this stuff, if I were to use a T-chart and I use 1 times 12, 2 times 6, 3 times 4, and I say 1 times 20, right, 2 times 10, 4 times 5, I both know their biggest number they have in common is 4. Okay? So that means that I can divide it by 4 over 4 and end up getting 12 divided by 4 is 3, 20 divided by 4 is 5. Comparing 3/8 and 3/5. Okay. Or you can even make it you can make this 6/10 as well. But the bottom line, stuff like this makes no sense. They're not adding, subtracting, all this. If I were to compare these two fractions, and I see they have a 10, 16 here. So instead of making this super small, I'm just going to make it, I can actually divide this. To make it equal 6/10, I can divide it by 2 over 2. And 20 divided by 2 is 10. 12 divided by 2 is 6. And so now I compare 6/10 with 3/8. 10 times 3 is 30. 6 times 8 is actually 48. And so I know this is greater. 6/10 is bigger. So let's see it. This one says 6/10 is smaller than 1/2. Let's check that. Let's make sure it's really smaller. I haven't checked 1/2. So 6/10 spread 1/2. 10, 12. It's greater. So that means D is wrong. So here we go. B is right. Again, there are 2 trick questions, and one you have to try it out and see which one is telling you the truth. All right. I see a 10. I see a 14. I can actually divide this and, divide it by 2 over 2 and end up getting 10 divided by 2 is 5. 2 divided by 2. Yeah. Also, I can divide this by 2. I can divide them both by 2. 8 divided by 2 is 4. 14 divided by 2 is 7. So it's going to be 20. It's going to be 14. So I can see here 20 is obviously bigger. So that means 2/5 is less than. Okay. So here, look at this. We got 2 saying that 2/5 is bigger. And again, 2/5 is not bigger. It's actually less. And 2 saying that it's greater. Now, the because clapper is the reason. This one's saying it's smaller than 1/2, larger. So that means we also had to compare this to 1/2. So I'm going to compare 4/10 with, I simplified it to 2/5. So I could say 2/5 divided by, no, I'm comparing that to 1/2. 4. Oh. So 5 is greater than 4, which means that 1/2 is actually larger. They're saying 2/4 is larger. That means saying that it's greater than 1/2, which is a lie. We already know 2/5 is less than, because the alligator mouth eats 1/2. So we know it is smaller than 1/2. And we also know that we need something that says 4/7 is greater. Alright, so here we go. That's our answer. Alright, this is it. I hope this helps. Have a blessed day.